Hi everyone, I'm Boting. Today we are going to talk about the sums of powers formulas. So we have three formulas here: the sums of k power 1, the sums of k squared, the sums of k cubed. So we actually have many methods to prove it, but today we're going to talk about the Gauss methods and the proof by induction. So let's go through it. The sum of k. So this symbol actually means that the sum Sn is equals to 1 plus 2 plus 3 plus until n. And we found that we can actually rewrite this equation as Sn equals to n plus n minus 1 plus n minus 2 plus onto 1. So we note as equation 1 and equation 2. We found that if we sum the equation 1 and the equation 2 Sn will be n plus 1 plus n plus 1 plus n plus 1 plus onto n plus 1. Because for example, like 2 plus n minus 1 is also n plus 1. 3 plus n minus 2 is also n plus 1. So how many terms we have here? We found that actually in equation 1 and equation 2 we both have n terms. And because we plus them one by one, so we still have n terms here. Which means we can write 2Sn as n times n plus 1. So Sn will be n times n plus 1 divided by 2. So finally, the sum from k equals to 1 plus onto k equals to n, it is n times n plus 1 divided by 2. So proof done. Okay, the next one, we're gonna prove the sums of k squared. It is equal to n times n plus 1 times 2n plus 1 divided by 6. So we're gonna use the proof by induction. So the symbol actually means 1 plus 2 squared plus 3 squared plus 2n squared. So we let the Pm be the statement as this formula. And first, because it's induction, we're going to prove the base case. So P1, well, obviously 1 squared is equal to 1. And also we sub k equals to 1 into the equation, into the formula. 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6 is 1 times 2 times 3 divided by 6, which is exactly equals to 1. So P1 holds true. Now we assume Pn is true. Well, namely the sum of k squared is this formula. And we want to show Pn plus 1 is true. Namely, we want to show the k squared from k equals to 1 onto n plus 1 is n plus 1 times n plus 1 plus 1 times 2 times n plus 1 plus 1 divided by 6. So, because we already know that if we plus from 1 plus 2 plus 2 squared plus 3 squared plus onto n squared, it is equals to n times n plus 1 times 2n plus 1 divided by 6 by the induction hypothesis. So this is true hypothesis. Then if we plus n plus 1 squared from both sides, okay, then we can factorize the right hand side. So first we take out n plus 1 because they both have n plus 1 this term, right? And then we found that it's gonna be n times 2n plus 1 times 2 times of n plus 1. And we want to factorize this. So we write it in the left, okay? 2n plus 1 plus n plus 1. This is equals to 2n squared plus 7n plus 6. So this can also be factorized. Okay, then it's gonna be 2, 1, 3, 2, gonna be 2n plus 3 times n plus 2. Okay, then we rewrite this, n plus 1 times 2n plus 3 times n plus 2 divided by 6. Well, this is exactly n plus 1 times n plus 1 plus 1 times 2n plus 1 plus 1 divided by 6. So pk plus 1 still holds true. Then we can conclude that by the principle of mathematical induction, for all the k inside z plus, this formula is true. And now the last one, we want to prove the sums of the k cube is equal to n squared times n plus 1 squared divided by 4. We still use proof by induction. Now we let Pn be the statement. The sum of k cube is equal to n squared times n plus 1 squared divided by 4. And still the same, we're gonna prove the base case. So obviously 1 cube equals to 1, and we substitute k equals to 1 to the equation, to the formula, we still can have 1 squared times 1 plus 1 squared divided by 4 is 1. So P1 holds true. Now we still the same process. We assume Pn is true, and we want to show Pn plus 1 is true. Namely, we want to show the sum from k equals to 1 until k plus 1 cube is equal to n plus 1 squared times n plus 1 plus 1 squared divided by 4. Okay, so same, we can write the sum of k cube into this one. 1 cube plus 2 cube plus 3 cube plus until n cube. It is equal to n squared times n plus 1 squared divided by 4. This is by the induction hypothesis. So same, we plus n plus 1 squared, n plus 1 cube, sorry, from both sides. And then we want to factorize the right hand side, the same. So we take out n plus 1 squared, same, because they both have n plus 1 squared this term. And then the rest would be n squared plus n 1 times 4. Okay, and this one still can be factorized. The n squared plus 4 times n plus 1. So we can write as n plus 1 squared times n plus 2 squared divided by 4. So this is exactly n plus 1 squared times n plus 1 squared divided by 4, which is exactly same as the equation we write here. So pk plus 1 is also true. Then we conclude that by the principle of mathematical induction, for all the k inside z plus, the sum of k cube is n squared times n plus 1 squared divided by 4. So this is the proof of 3 formulas using induction and Gauss methods. So hope you like it, and thank you everyone.